Hello everybody, my name is DEBASIS Dash. Today is the fourth day of our assignment. These four questions are the assignment for today. So the first question is, what are different algorithms on which load balancer works? Please explain at least 3 algorithms with example. So the different algorithms on which load balancer works are round robin algorithm, weighted round robin algorithm, and source IP hash algorithm. So the first algorithm is round robin algorithm. A batch of servers are programmed to handle the load in a rotating sequential manner. This algorithm assumes that each device is able to process same number of requests and is not able to account for connecting devices. The second algorithm is weighted round robin algorithm. So servers are rated based upon the relative amount of requests each is able to process. Those having higher capacities are sent more requests. Then the third algorithm is source IP hash algorithm. It combines source and destination IP address in a request to generate a hash key, which is then designated to a specific server. This lets a dropped connection be returned to the same server originally handling it. Then the second question is, mention at least 5 different use cases where you think cron job is set in the applications you use on a day-to-day basis, such as Instagram, FB, YouTube, Google, Flipkart, Amazon, etc. So the 5 different use cases are daily backup of messages and media to Google Drive in WhatsApp, then show previews of notifications at the top of the screen in WhatsApp, show messages and media, show notifications of messages and media at the top of the screen in Telegram, then send notifications about account and content in Facebook, then get all the notifications as a daily digest at 19 p.m. in YouTube. Then the third question is, create a document to explain New Relic Dashboard with screenshot so that the video which you have watched, other person need not to watch it and understand what are different things on New Relic Dashboard and what is their use. So this is the New Relic Dashboard. We will explain every components of New Relic Dashboard one after another. So the New Relic Dashboard shows a set of key performance metrics which allows to quickly determine the health of a application. These data show where to drill for more details to troubleshoot the performance problems. Then time picker. Time picker allows to select the time context which is shown in all the chats on this dashboard. So here we can select the time context, that is 30-minute, 60-minute, or 3 hours. And here also we can select custom date, in which we can select the ending at time and any particular date. Then JVM. Here we can see that JVM indicates aggregate data of all the 4 hosts. Here we can see that there are total 4 hosts or 4 servers. So if you want to see data of any particular host, then we can select that one and we can see the data of that particular host. Then web transaction time. Web transaction time is like the speedometer of a car. Web transaction time represents the average response time of all transactions of applications over a time window we have selected. So here the entire response time is has broken out into 4 categories. Those are JVM, Redis, MySQL, and Web External. Here the JVM represents for Java. So here JVM indicates application code or server side code. So here JVM is indicating the portion, what portion of this entire response time is spent for executing the code. Then the web external. This web external represents what portion of the entire response time is spent to call the external service and waiting for the data to come back. Then this application retrieves the data from 2 data stores. Those are MySQL database and Redis cache. Here we can't able to see the Redis cache because Redis cache here is consuming less time, so that it is in memory. So that's why we can't able to see the Redis cache here. Then AppText score. And the right hand side, we can see the AppText score chat. Here in the square box, we can see 0.15 seconds. This one, 0.15 seconds is the AppText threshold. Then this 2.5 seconds is the page load time threshold. Then 0.15 second means here the server side code takes 0.15 seconds to respond, and 2.5 second means here the browser takes 2.5 seconds to load. So in the left hand side, we can see 0.99. So this 0.99 is the AppText score. So from this, we can know that this application is running well because it is hitting at the 99% of AppText score, AppText threshold. And but this browser is not working that much well because it is hitting at 83% of the page load time threshold. Here we can see that in the box, individual data points are there, and we can calculate the data and we can calculate the score at this point on this chart. Then throughput score. Below the AppText score, we can see that throughput score chat is there. So this throughput chat represents the number of requests receiving by this application per minute over the time window. So here we can see that this line is averaging little above the 2000 requests per minute. We can see that there are so many peaks are there in this line. So it means it is receiving so many requests so that it is under heavy load. So we can see the corresponding spikes over the response time so that it is getting slower. That means it is under heavy load. Then transaction. Here we can see that these are 5 slowest transactions of these applications. Then the average response time of login transaction is 1210 milliseconds. Then we can see that 1.6 second, 1.5 second, 1.4 seconds are not the average response time. Those are the slowest response time of individual executions. By clicking those hyperlinks, we can know more about the individual executions. Like that, we can click the individual transaction bars so that it will be redirecting to the separate transaction pages so that we can know more about those transaction details. Then we can click the transactions heading so that it will be redirecting to a separate transaction dashboard, and from that we can analyze all the transactions. Then error rate. Error rate represents the percentage of number of all the transactions upon which how many of those returned an error. So here we can see that there are some spikes are there. These spikes are the in this spikes over those time windows, the error rate was higher. Then application activity. In this application activity, the first tab is in progress. In progress, we can find all the notable events that has occurred in this application. Then the event log. In the event log, we can see the notable events in the reverse chronological order. Then by using the filter option, we can see a particular kind of data by choosing the datas. And here we can also see the subset of these datas. Then host. Here we can see that there are 4 hosts. From the container icon, we can see that these are Docker containers. If we want to know the infrastructure of these hosts, then we can click the hyperlinks of those hosts so that we can able to know the detailed infrastructures of this host, what changes have been made, who is logging in, and what are the processes. All these data we can know from those hyperlinks. Here we can see that there are number of key performance metrics data are there, like memory usage, CPU usage, error rate, throughput, then response time. So in this list view, if so many number of hosts are there, then it will be difficult to analyze the key performance metric data of these hosts. So for this, in the top, we can see that there's a widget is there. This one is break out each metric by host. So by clicking this widget, we can get this type of graph. So by this type of graph, we can easily analyze and compare the hosts by this key performance metrics data. if we will put the cursor on a single line, then the line representing the hosts will be jump over, and we can see the um, data, key performance metrics data of that particular host or line. Then the fourth question is list out different use cases where we can use AWS Cloudwatch. The different use cases where we can use AWS Cloudwatch are to collect and track metrics, collect and monitor log files, and set alarms. So that's all about today's assignment. Thank you.